students, it's day 2 for the chapter sound. In previous lecture, we have discussed what is an echo, determination of speed of sound by the method of echo and use of echoes. The specific objectives of today's topic are free vibrations and damped vibrations. Now, our first topic for today is what are free vibrations. Actually, when a body is clamped at one point, clamped means fixed at a point, and is slightly disturbed from its rest position, it starts vibrating, and the vibrations so produced are called free vibrations. So, free vibrations can be defined as the periodic vibrations of a body of constant amplitude. Constant means same amplitude. As you can see in the diagram also, the amplitude remains constant, are called free vibrations. Students, these vibrations occur in the absence of any external force. That is why their amplitude is constant. Second point, the period of vibration. Period means frequency of vibration. It depends upon the shape and size of a body. And the time period of a freely vibrating body is called its free period. And the frequency of freely vibrating body is called as its natural frequency. Now, let's discuss the examples of free vibrations. If the bob of a simple pendulum is displaced slightly from its mean position, it starts vibrating. You can see a vibrating pendulum, and it starts vibrating with its natural frequency. As you can see, its amplitude is constant. It is vibrating with a fixed amplitude, constant amplitude. So, this gives an example for free vibrations. Different pendulums of different lengths. This is the length of the pendulum, and every pendulum has its own length, and they vibrate with their own frequency, own different frequency with the constant amplitude, showing an example of free vibrations. One more example is there. You can see a load is suspended from the string. When stretched or compressed and then released, it starts vibrating. It starts vibrating with its natural frequency. Showing one more example of free vibration. Nature of free vibrations. The free vibrations are the simple harmonic vibrations under the effect of restoring force, the amplitude and frequency of which remains constant. This is its amplitude, that is the maximum displacement of the particle from its mean position, and frequency is the number of vibrations produced by a wave in 1 second. Its amplitude and frequency remains constant under the effect of its restoring force. Once a body starts vibrating, it continues its vibrations with the same amplitude and same frequency forever. But is this actually possible, students? No. The free vibrations can only occur in vacuum. Why? Because there are resistive forces which are present in the atmosphere, which will not allow the particle to execute free vibrations. It is very difficult to realize such vibrations in practice. In practice, the surrounding medium offers resistance to the motion, so the vibrating body continuously loses energy, due to which the amplitude of motion gradually decreases. It starts decreasing, and that vibrations are called as damped vibrations. Now, defining damped vibrations, the periodic vibrations of a body of decreasing amplitude. You can clearly see in this graph, the amplitude is decreasing with time in the presence of a resistive force are called the damped vibrations. Some examples of damped vibrations are when a slim branch of a tree is pulled and released, it makes damped vibrations as they slowly come to rest. A turning fork, when stroked on a rubber pad, that is, when it is hit on a rubber pad, it executes damped vibrations in air. And third is the vibrations of a spring having a mass at its end in air are damped vibrations. Difference between natural and damped vibrations. Natural vibrations. The amplitude of natural vibrations remain constant and vibrations continue forever. Whereas for damped vibrations, the amplitude of damped vibrations gradually decreases. There is no loss of energy in natural vibrations. In damped vibrations, there is always some loss of energy. No external force acts on the vibrating body and the vibrations are only under the effect of restoring force. Whereas in damped vibrations, in addition to restoring force, a frictional or damping force, that is a resistive force, also acts on the body. Last is the frequency of vibration depends upon the size and shape of the body as it remains constant, whereas in damped the frequency of vibration is less than the natural frequency of the body, and the decrease in frequency depends upon the damping force, that is the resistive force which is acting on that vibrating body. Just see the difference between natural vibrations and damped vibrations. For natural vibrations, you can clearly see the amplitude of vibrations remains constant. This black line can show you that. And second is damped vibrations, you can see the amplitude is decreasing. There is no loss of energy in natural vibrations as its amplitude is constant, whereas in damped there is always some loss of energy. The frequency of vibrations remains constant in natural vibration, whereas in damped the frequency changes and it is always less than the natural frequency of the body. So, this ends up the topic for today. Thank you.